Calculus BC, we're looking at More on Integrals, worksheet number 1, and problem number 3. We're continuing our discussion on problem number 3. Our last video, we were addressing part C, where we were looking for an absolute maximum velocity. And just to review something, when you're finding the absolute maximum for a function, you're really using the extreme value theorem. If you're working on a closed interval, which, by the way, we are, you can see right here with that 0 to 18 right here. You want to check the endpoints, of course, and we talked about that. Now, real quickly, we did do a number line, and you can see we had that number line off to the side. We knew that we would expect a relative max at 6, a relative minimum at 16. We found the velocity at 6 by working out an integral, realizing the integral was a change in the velocity on a time interval. We added that change back to what we started with, and we found our velocity at 6. At 0, at t equals 0, they were very kind. If you look up at the top of the screen, I'm circling it right up here, they told us that we started with 55 feet per second. Of course, the right endpoint is another matter. And of course, sometimes kids will say, shouldn't we also find the velocity at 16? Wouldn't that be important also? Well, we know it's a relative min, but maybe, just maybe, it will still help us out. First off, let's come back here and maybe just address, we stopped at 12, and maybe somebody could bring up that at 16 they have a lingering question. Hey, could this perhaps maybe somehow relate to another velocity value? Maybe you just want to know what that velocity is. That's not a bad thing to figure out. Look, we've got a blue trapezoid here from 12 to 16. 16 minus 12, well, that's 4. Look at 12, if we bring that down here, here's a 12 right here. From 12 to 14, right here, that's really what we've got. 12 to 14, that would be a 2. And, I'm going to draw this little trapezoid off to the side here. We know that up here is 4, down here is 2, and the height of that, the distance between is 15. So we could take the area to be 1/2 base 1 plus base 2 times the height. 4 plus 2 is a 6. Half of 6 is 3. 3 times 15 is actually 45. So that's a negative 45. And guys, right there, that tells you so very, very, very much. Look, I guess what we can most definitely continue to talk about here, and maybe you want to, go off to the side a little bit. As we're integrating between 0 and 12, we saw that the 60 and the negative 60 would cancel out. If we are integrating between 0 and 16, well, think about it. In yellow, that negative 60 would cancel, the positive 60 would cancel with the green negative 60, that's 0. And then we'd have this blue area, that negative 45. It's below the x-axis. This is your change. This is the change that you have. So what did we start with? Well, look, right below where I'm writing, you're starting with a velocity of 55 feet per second. Then what? Well, you add where you change. You're going to wind up going down 45 feet per second. That's 10 feet per second. And I know that's not really even a possible absolute maximum, but sometimes kids still want to address that. We can see right here, V of 16 is going to be a 10 feet per second. And of course, we knew that would be a relative minimum. But then when we look at what's happening between 16 and 18, well, wow, between 16 and 18, here's a triangle. And in this triangle, Well, maybe we can make this jump out in red, perhaps, just to really point out that this right here is going to be positive area. And we can see from 16 to 18 is 2. This goes up 15. 1/2 base times height. 1/2 of 2 times 15. Well, the 2's cancel out. You're left with a plus 15. Well, this hopefully can help you out in terms of knowing what's happening on that interval from 0 to 18. Look, I'm going to bring this back down here. We can say from 0 to 18, if I were to look at this, which is the change in velocity from 0 to 18, we can see if we went back up here, we had a 60 and a negative 60. These wipe out, don't they? They're completely gone. And we have a negative 45 and a 15. Well, if you add those two up, negative 45 plus 15, you can see it's negative 30. That's negative 30 feet per second. What is that? That's the change in velocity on that time interval. So what did we start with? Well, we said it before, we're starting with 55 feet per second. That's what they told us. And then your change, because it's negative, you're going down 30 feet per second. Well, that's 25 feet per second, isn't it? And guys, that's what you have right here. So right now, you can answer the question, what is the absolute maximum and at what time does it occur? Well, we can say that our absolute maximum velocity is 115 feet per second at t equals 6 seconds by the extreme value theorem. When they say justify your answer, well, we've checked the endpoints. We've checked our endpoints of 18 and 0. We've checked also where our derivative is 0 at v of 6. We didn't even have to check v of 16 because we did do a number line. But I really liked finding this too, because now we can answer our last question. The last question is, at what time, if any, is the car's velocity equal to 0? Well, here's for part D. The car's velocity is never 0. The absolute min velocity is 10 feet per second at t equals 16. And that's the end of the problem.